this really matters then for climate, right? So this increase in carbon dioxide has really, really dramatic impacts on climate. Okay, so um, there's not a whole lot of good news. So I always like to point out, right, that there is some really, really good news in the climate world. And that is, well, it's good news in that it could be a lot worse than it was, so than it is. Right, so we're right now in 2021 at about 420 parts per million. Again, that goes up and down a little bit. Um, Pre-industrially, we were at 270 parts per million. So we've gone way up. But really, we're lucky because we should be about 570 parts per million. And what I mean by that is if all of the carbon dioxide that humans had put up into the atmosphere from fossil fuel burning and cutting down rainforests, all those sorts of things, if that carbon dioxide had all stayed in the atmosphere, we would be at 570 parts per million. But good news for us, about half of that CO2 that we're putting in the atmosphere is not accumulating in the atmosphere, and that brings us down to 420 parts per million. Of that carbon dioxide that isn't accumulating, about half of that, so ultimately a quarter of the carbon dioxide that we're putting into the atmosphere, is going into oceans. That has implications for ocean acidification and the corals and other organisms that live in oceans. So that keeps oceanographers up at night, thinking about that these days. But then that other half of carbon dioxide that isn't accumulating, that's coming back into land, right? So, and that's really mostly plants and soils. So plant biomass, that there's just more plants now than there have been historically. Globally, if we look across the whole globe, and then there's more in some places. There's more carbon that's accumulated in soils. So this is really good news, right? Because our climate has changed, and there's a lot of very worrisome news with that. But despite 420 being kind of high relative to our pre-industrial 270, 420 parts per million is a lot less severe than if we were at 570. So this is really good news. Then this becomes sort of a question, right, of what's going to happen with this, with where this extra carbon dioxide is going in the future, right? Are we going to have that extra, place that carbon dioxide is going? Is that going to continue going there in the future? Is it maybe we'll be really lucky, like the green line here, and things will change. Biological processes or chemical processes will change, and there will be more carbon dioxide taken up by this, these processes. Or maybe they'll be saturated, or things change, and carbon dioxide gets released from those in the future. So that's I spend a lot of time thinking about those questions, and so trying to project what atmospheric carbon dioxide looks like in the future really depends on human activity. Fortunately, that's way out of my purview, but other people work on that. And so far, we haven't done a great job of reducing emissions. But we do know, right, that oceans and terrestrial land masses are acting as I wrote here, as like a sink, a place where carbon dioxide goes. So that's really positive, but we just don't know what the future trajectory there might be. So a really important part of this is soils, right? Soils and plants, and that if we look at soils, the yearly amount of carbon dioxide that's released from soil, so soil respiration, which is the process of release of carbon dioxide from soils, that's 10 times as much as fossil fuel combustion, right? Globally. So soils are releasing a huge amount of carbon dioxide into the atmosphere. So understanding where and what controls that release of carbon dioxide is really important in terms of trying to understand what our future, what our future climate might be. On the other hand, most of this soil respiration is balanced out by photosynthesis. So there's uptake through plant photosynthesis and then release of carbon dioxide out through soils. But if there's some sort of imbalance in those that leads to potential of carbon being stored in soils, or as well as carbon being stored in plants, that could have really important implications for climate. So there's been a lot of work really trying to figure out, where is this carbon going, right? Like, and now actually this has moved on a lot and how can we make there be more carbon stored on land, right? Are there things we can do to increase carbon storage on land, particularly in ways that will not have negative impacts for humans or natural systems? Or even better, enhance our lives in some ways and enhance our natural systems. So if we sort of partition out where this carbon is going, it turns out in the United States, there's a huge amount of carbon that's being stored by just the landmass itself. And one place that a lot of that goes is woody encroachment. And I'll explain what woody encroachment is and why it relates to deserts in just a minute. But just to give you an idea of how much carbon we think is being stored there annually. So this estimate was 0.12 to 0.13 petagrams of carbon per year that are being stored through this process of woody encroachment. So to give you a sense, 1 petagram is 10 to the 15th grams of carbon. That's a really, really big number that makes no sense to me because I can't, it's too big. I can't understand it. So I calculated that out then to be 271,338 fully loaded Boeing 747-8 series airplanes. That was the latest version of Boeing 747s. I know they're like pretty much defunct now, but massive airplane. And if we put those wingtip to wingtip, like this image up here in the right corner, they would go 3 times across the continental US. So that's the amount of carbon that we're talking is being stored through this process of woody encroachment. Okay, so what's woody encroachment? So this seems potentially important and interesting for carbon cycling. Woody encroachment is an increase in trees and shrubs, and it's occurring in about 40% of our land area worldwide. And it's not a perfect overlap, but it turns out that a lot of that area is dryland systems. So this is occurring in many dryland ecosystems. And so me and my students have been working for quite a while now to try to understand, how does this change in plants that we have, particularly in deserts? How does that influence atmospheric carbon dioxide? And that the desert, we're coming to understand that desert ecosystems now look really, really different. Or many of them look very different than they did 150 years ago. And so an example from a site that I work at in southern Arizona, so this is a site that's south of Tucson. If we were able to visit that in 1902, it would look like this. So this is a historical photo we have, a nice horse-drawn carriage there going through the grasses. There's a couple cactus there, but not much else. By 1938, we have a lot more cactus. And in the background here, we start to see some mesquite shrubs popping up. By 1971, a lot more mesquite. This happens to be kind of a year with a lot of rain. There was a lot of grasses there. And then 2003 happens to be a dry year with not a lot of grasses, but we see a lot of cactus, a lot of mesquite shrubs. I have a hard time walking through this area without getting stuck by cactus as I'm walking through. Let alone, can you imagine trying to drive a horse-drawn carriage through there? Like, impossible. And this sort of pattern has happened in dryland systems worldwide. And so we think that there's a lot of reasons and a lot of ways in which dryland systems have influenced carbon cycling. But this is one, this kind of large scale change in vegetation is one mechanism that seems to be really important. And so we're working to better understand how do these patterns change the amount of carbon that's stored in plant material. It turns out the plant part is kind of the easier part of the equation. You can walk around or take photographs, even use aerial photography and remote sensing like satellite images to look at the number of trees. A harder question is, how does that change carbon in soils and the processes that influence the amount of carbon that's stored in soils, and under what conditions that carbon is released from soils? But we are working on that. We've starting to better understand the processes that control that. And right, with that, I think I have taken probably all the time that that Stephanie has allotted. I'm happy to take questions if there's any time for that. So.
I think we had a little extra time in today's workshop. Correct me if I'm wrong, Kelly. So I think that we could take a couple questions, and there has been some discussion in the chat about oxygen levels in the atmosphere. I don't know if you can see the chat now, but
let me just open that up. Oh, yeah.
Stacy was wondering about the percent of oxygen in the atmosphere and the relative percent as carbon dioxide increases. Will oxygen become scarce?
Yeah, so that's a great question, Stacy. Because absolutely, as we have an increase in carbon dioxide in the atmosphere, we have a decrease in oxygen. So that is absolutely true. However, and we see, Jay Hartley there has provided a great answer. Yeah, that the thing is, right, that we have for historical reasons, we've had this long-term accumulation of oxygen in the atmosphere from deep back in our biological and geological history. So there was accumulation of oxygen, so that we're somewhere around 18% or so oxygen in the atmosphere. And then we're at, what did I say? We're up to like 420 parts per million of carbon dioxide. So we would, I haven't done the math of like exactly how much we'd basically have to, have huge, unfathomable increases in the CO2 concentration in the atmosphere in order for that oxygen to be consumed. We've just had this long-term accumulation. And so it's not, while that oxygen is absolutely vital for us to be in the atmosphere, it's really hard to imagine that we could in any way change that oxygen. So we are safe from an oxygen perspective.
Thank you. Are there any other questions for Dr. Troop? You can unmute yourself and ask them, or put them in the chat. We might have time for one more.
Yeah, Stacy. Yeah, yep, exactly. So hopefully it won't kill us, but yes, I think yeah, definitely changes in climate are much more worrisome than changes in oxygen levels. There we go. Yeah, 0.042%. Yep. So tiny amount of CO2, and which is kind of weird, right? That it's a tiny amount of CO2, but it's just that CO2 is just incredibly effective at trapping heat within our atmosphere.
I have a question on the woodland encroachment, if I may. So if you're getting woody plants coming in there, are those forcing out the grasses?
Yeah. Oh, that's a great question. Yeah. So there's been. I would say it varies. There are definitely places that is the case, where that we just have this wholesale shift in vegetation, and there's been a lot of concern from people who have livestock, right? So ranchers have been, they rely on grass production for livestock production. And so actually within the Southwest, then there's quite a few programs, and there have been for the last 100 years or so, to try to stop woody encroachment in order to increase grass growth. It doesn't always necessarily happen that way in terms of there's a couple potential outcomes, right? It's always a little bit more complicated. So there are sites, for example, that I work in Arizona, where we've had shrubs come in and the grasses are still pretty intact. And in fact, we have really high density of grasses underneath the shrubs. I think because there are different species of grass, but that they just do better under the shading of the mesquites.
Exactly.
So yeah, so there are cases where it does, there's cases where absolutely we lose grasses. There's cases where we don't lose grasses. And there's cases where it's a little bit hard, like we have a shift in vegetation. It's hard to know, like, is it because the shrubs came in that the grasses were, that they were pushed out by competition, or is it that other factors like in some sites, certainly there's loss of grasses through grazing or other activities that have led to erosion. So we lose the surface soils.
Right.
Grasses can't come back in, shrubs can. So it's not really the cause, but you get this pattern of loss of grasses and increase in woody plants.
Fascinating problem. Thank you.
Wonderful. Well, thank you so much, Dr. Troop, for joining us today. You are welcome to hang out or hop off if you need to, but we're really grateful for your time today. And that was super informative. Thanks so much.
All right. Thanks so much for inviting me. It's always fun to see you guys. Asombro, you're amazing as usual. So I would love to stay, but unfortunately I have another meeting that I've got to jump to. So I will sign off now.
All right, take care. Thanks. Kelly, you're muted.
Thanks. Had to find the button. All right, we'll continue on with and jump into some activities that we'll be looking at today. I think most of you have been here for these before, so I'll just real quickly remind you that every activity we'll be covering today is a part of our Southwest Climate Hub materials that Asombro publishes on the Southwest Climate Hub webpage. There's 17 lessons there in the 3 units of climate change and the water cycle, climate change and the carbon cycle, and the effects of climate change on agricultural systems. We'll be doing a little bit from each of those today. And the best place to access them all is asombro.org/climate. Oops, not that one. This one. That page looks like this, and you can see there each of the units, as to them. The water cycle is in both English and Spanish, so the others are just in English. And when you click on Access the Curriculum, it will take you to a page that looks like this, where you can see all the lessons organized by the days of kind of, if you want to do them all together as a unit, how we suggest looking at them. You can look at them all together if you want, including with the standards. They're all next generation science aligned as well as Common Core. And then the agriculture unit is also aligned with the agriculture, food, and natural resource standards as well. But there also, you can see everything here. There's an educator guide, handouts, PowerPoint presentations, instructional videos. So everything you might need to prepare yourself to teach these lessons and then give to your students is all here. So I'm gonna head back to this page, our slides. We are gonna start today with one of our favorite activities that we use all the time called Insulating You, Insulating Earth. And I'll hand it over to Stephanie.
Thanks, Kelly. So, right, so we developed a really neat experiment that models the greenhouse effect. And we actually use the same experiment as part of 2 of our lessons. One's in the water cycle, climate change in the water cycle unit, and the other is in the carbon cycle unit, or climate change in the carbon cycle unit. And it's the first one, Insulating You. Insulating Earth is really great for middle and high school students. And the second one, The Ins and Outs of a Climate Feedback Loop, is more appropriate for high school students, and it's aligned to the high school standards. So this experiment only requires simple supplies. For each group of 3 to 5 students, you'll need a thermometer. We like this type of meat thermometer that's pictured here in the photo on the left, and also on the far right. It has a wired probe and a separate digital display screen. It is possible to use other types if you don't have access to these or can't pick some of these up. You'll need a small binder clip, a stopwatch, or of course you can have your students use their phones, a towel, and a space blanket. It's also known as a Mylar blanket or an emergency blanket. And so, like I said, it's super simple materials, and we keep it that way so that everything's really accessible and easy to use. I'd like to show you a quick snippet of a video that will show you how to, this goes along with the Insulating You, Insulating Earth lesson. And this is the instructional video, and this will show you how it's set up. So here's
Once the roles are assigned, the test subject should use the binder clip to attach the thermometer to their pants. The thermometer should run parallel to their legs, and the probe end should be pointing towards the torso, not the knees. Tell students to check the current temperature on the thermometer. It can take up to 5 minutes for the thermometer to acclimate to the student's body temperature. So use that time to explain the experiment and introduce the greenhouse effect. After 5 minutes, the thermometer should have stabilized around the student's body temperature, and you can begin the experiment. At this time, the data recorder should record the initial temperature. The materials manager will give the towel to the test subject, who lays it across their lap and tucks the ends under their legs if possible. As soon as the towel is placed, the timer starts their stopwatch. The timer and the data recorder will work together to record the temperature every minute for 5 minutes. After 5 minutes, the test subject should remove the towel from their lap, but leave the thermometer. The thermometer needs 2 to 3 minutes to return to close to the initial temperature before the next trial. While they wait for the thermometer to stabilize again, students can make sure that everyone's data table is complete and do subtraction problem A on their handout. Once the thermometer has stabilized near the initial temperature, the data recorder should record the initial temperature for the towel and Mylar blanket trial. The materials manager will give the test subject the towel to place on their lap as they did before. Then the Mylar space blanket will go on top of the towel, and again tucked under the legs if possible. As soon as the towel and space blanket are in place, the timer will start their stopwatch. Students will again record data for 5 minutes. After 5 minutes, the test subject can remove all the materials and everyone can complete their data table and subtraction problem B on their handout before discussing the data as a class.
All right, so that kind of gives you an idea of how the experiment is set up. You can see there's one trial that's just the towel by itself, and then the students add that Mylar blanket and see how that affects their trial. So here's how the analysis will look. This is for Insulating You, Insulating Earth. There's some example data on this slide. And so the students first calculate the differences. And what they do is they take the final temperature at 5 minutes and put that in the first blank of the subtraction problem. And then they put in that initial temperature of their lap and calculate the difference. Then they do the same exact thing for the towel plus space blanket trial. So they take that 5 minute temperature, subtract the lap temperature from it, and calculate the difference there. then either on the board or with a document camera, you'll use the whole class data to gather the differences for the towel trial and then the towel plus space blanket trial. And students will calculate those means for each of those trials. So what they'll see after analyzing the data is that the space blanket results in higher temperatures. And after analyzing the data, they describe how that model represents the natural greenhouse effect and the enhanced greenhouse effect. So the Mylar blanket is modeling the addition of greenhouse gases to our atmosphere, and students can see using their own, body heat that the addition of greenhouse gases is going to affect the temperature on Earth. So it's like one blanket is a good thing, right? 2 blankets, you might get a little too warm. So let's not put 2 blankets over our Earth, is what we tell the kids. The ins and outs of a climate feedback loop, like I mentioned, is the one that is more appropriate for high school. So this experiment is slightly different. The groups are split in half. So half of your students in the class will do the towel trial, and that's all they'll do. The other half will do the towel plus space blanket trial, and that's all they'll do. So that makes the data analysis slightly different, but it gives us a little bit more time to go into depth with some of the analyses for the high school students. So the data analysis, they collect the data for their group. And then again, you will compile the whole class data, either using a document camera or put it on the whiteboard. And then the students calculate the mean of all the students who did the towel trial, and then all the students who did the towel plus space blanket trial. So that leaves us some time to get into this idea of a positive feedback loop. Positive feedback loops are destabilizing. So they use they can relate this back to that space blanket experiment. That's the addition of carbon dioxide to the atmosphere. That's what they're modeling with that experiment. Then they can relate the temperature. So they see that that results in an increasing temperature. And then through other parts of this lesson that we're not going to have time to go into depth about today, they learn that increasing temperature leads to melting ice and thermal expansion of water. As water warms up, it expands. So with that, then we see sea level rise. And because the sea level is rising, we are seeing destruction of coastal wetlands. Coastal wetlands are actually some of the biggest sinks for carbon on Earth. And so as these coastal wetlands get destroyed, not as much carbon dioxide is being taken up, and then it's feeding back into this feedback loop of increasing carbon dioxide in the atmosphere because not as much is being taken up by the habitats that are being destroyed. So this is a really good, this next generation science standard is challenging for some teachers to meet the part about the feedback loop. So this is a great lesson to use with your high school students to meet that NGSS. All right, awesome. And with that, I will go ahead and stop sharing. And I will pass it off to Kelly, who's going to tell you about another fun activity.
All right. So with this topic of Earth cycles, we're going to hit on a bunch of different cycles. So we've got carbon cycle, and we're going to spend some time on the water cycle, as well as how is climate change impacting the water cycle. And Washed Away is a lesson from our climate change, the effects of climate change on agricultural systems unit. And just a question for you all, feel free to shout out or put an answer in the chat, but what do you think of when you hear the phrase extreme precipitation? Flooding, yeah, absolutely. Hurricanes, Abby's from the south. Water pollution, city streets, flooding in city streets. Yeah, I heard Carlsbad, New Mexico. If any of you have been there, the streets were flooding the last couple of days from the river or the reservoir overflowing. Mudslides, increased warmer air, runoff. Yeah, absolutely. Thanks for that. Just brainstorming right there. Damage to infrastructure. Absolutely. So this lesson is about extreme precipitation, in particular how it affects agriculture as it comes to the agriculture unit. But all of these are true, and we do expect to see more extreme weather with climate change, right? So this one's really about erosion. So the first bit of this lesson is a demonstration of an extreme precipitation event on erosion, the effects of erosion on topsoil. And so there is a video that you can watch about this and how to set it up as well as what it looks like. But you can see here, there's two pans. This one's kind of propped up on a slope. There's a watering can raining down, but there's this dark soil, that's potting soil. And underneath it is some hard packed sand. And so when we have extreme precipitation, we often see a loss of topsoil. And so this activity really asks students to think about the impacts of that precipitation on soil quality. And as Dr. Troop was talking about soil nutrients, that all those nutrients, that's stored in the topsoil, the active soil that's taking up nutrients and respiring, whereas the stuff that's lower down and underneath is much less active in collecting carbon. So in Washed Away, students watch this demo and think about the topsoil washing away, and then they do some soil quality tests and think about extreme precipitation and quality of soil. And they test the topsoil or the potting soil compared to the lower layers or the sand. And the slides walk you through talking about the impacts of pH, nitrogen, phosphorus, and potassium on plants and their importance in soil. And they use soil tests to take a look at these. And these are soil tests. You can buy them at a home store, Home Depot, or any hardware store will have them. They're designed for looking at your garden, so they're pretty easy to find. And so students look at, they start their soil tests, and then they usually need about half an hour, at least 10 minutes, sometimes half an hour to develop. So while that's happening, students look at soil data and think about where, based on what we know, can we predict where are good places for planting, as well as where's most at risk for extreme precipitation and runoff. And they do that using this soil web data analysis. And so I'm going to send you to breakout rooms in a minute, but let me pull up Soil Web. I'm sorry, I should have done this before. So this is a app hosted by University of California, I believe. Yeah, UC Davis. And Soil Web is a national map, interactive map, where you can click on various locations and it gives you information about the soil. And there's a lot of codes that you might not know what it means, but the worksheets walk you through interpreting all of this and what you're seeing. And so you might have to look at the description here. It'll tell you what you're looking at, as well as what some of the soil classifications mean. So what I'm going to do is send you into breakout rooms now. There's a Google folder link that we're going to drop, Stephanie just dropped in the chat. And in that link takes you to a worksheet. And that in the folder, you'll note your breakout room number as you go in, and then click on that worksheet so you can do it as a group with your group. So Washed Away 1. There we go. So this is the student worksheet. It gives you the link to get to the soil web and all the instructions to fill out this data table and compare the nutrients at all of these places. So there's several listed: Hawaii, New Mexico, California, and then you can choose another, whether you want to choose your own location. You feel free, if there's people from all over, you can add another column to the table, and you can all fill this out together and compare. I'm going to give you 9 minutes to do this, so you can sorry, distracted by the chat. You can compare just 2 if you'd like. And then there's some conclusion questions that you can look through as well. Again, we just want to give you a little bit of taste, so you probably won't have time to do it all. But I'm going to stop talking and send you off to breakout rooms now. So Abby will give them 9 minutes in the breakout room. All right, welcome back, everybody. Glad to see you all made it. Well, so again, just a little time to take a little taste of that lesson. I know it's kind of confusing, but it's also really fascinating to look through the soil database and just see what's there. And I like the ability to explore different places. Stacy, do you have a question?
Yeah, we kind of got stuck at a point where it said click on the soil code, and we could see all these codes across the map, but they weren't clickable. So we kind of got stuck there.
No. I will ask Stephanie, do you know?
No, I'm not. I'd have to look at it with you. I'm not picturing exactly what section you could be talking about, but
we were on the map with all it looked like a topographic map, kind of. We were in Hawaii, so they all started with the W, most of them started with the W, but they weren't clickable, so we weren't sure what soil, where or what the soil code was that we were supposed to click on.
I'll look
what the
it up
direction
and
said.
We'll explore a little bit. Yeah, that's not good.
I'll look it up and tell you in the chat, just so you have an answer.
Well, and if I might say, I think it's important, if we're going to do this with our students, that maybe a video can be produced so we know where to click.
Or maybe another group who was successful can share what they did.
Yeah.
And I think it's been a long time, so Stephanie or Abby, correct me if you remember something differently, but I believe the slides, the slide presentation does have like click here with arrows and pictures all over it. So we didn't go into that today, obviously. But yes, that's really good feedback, and we can probably put together a video like that, because absolutely, it is a kind of like click around, see what you can find, and some locations are easier than others. So yeah, it's all a learning curve, and we love to hear this feedback, so thank you. So we're gonna transition to some other water cycle activities now. So that was extreme precipitation and soil quality, so bringing together the nutrients that Dr. Troop was talking about with the water cycle, and Abby can tell us about the water cycle.
All right, yeah. So like we just talked about with Washed Away, the water cycle is a super important Earth cycle that is being affected by climate change. The water cycle game is a really simple but helpful sort of review activity that allows students to model how water cycles through Earth's reservoirs. So kind of taking it a couple steps back and getting back down to the roots of what is really happening in the water cycle. And it provides a good background for understanding other lessons like Washed Away. There's an instructional video with this lesson, and I'm going to show you a minute of it that explains how students are going to play the game. To learn about the water cycle, students will play a game to model the processes that move water between reservoirs. Tape the 6 bin labels to the outside of empty storage bins or trash cans and spread them out around the room. You'll need one for atmosphere, groundwater, lakes and streams, land ice and snow, ocean, and plants. Place 12 paper balls into each reservoir bin. These represent water drops. Introduce the water cycle using the PowerPoint.
Explain that places where water is naturally stored on Earth are called reservoirs, and routes that water can travel between reservoirs are called flows or pathways. Divide students into 6 groups and give each group a copy of the water cycle diagram. Explain that the arrows indicate movement of water from one location to another, and they're labeled with the process that's moving the water. Thin lines indicate a small amount of water moving, and thick lines indicate a larger amount of water. Assign each group to a reservoir and have them stand next to it. Their goal is to move water from their reservoir to another using the process labeled on the water cycle diagram. Students can move 2 water drops into reservoirs connected to theirs with a thin arrow, and 5 water drops into ones connected by thick arrows. They'll need to throw the correct number of paper balls into the reservoir and say the name of the process that's occurring to move water. Have groups take turns one at a time throwing water drops into the correct reservoir. For example, the groundwater group could give 2 water drops to the ocean through groundwater flow. Then the plants can give 2 water drops to the atmosphere through transpiration. If it's not their...
All right. So that is a super simple overview of that game because it's a really simple game to play. And it's kind of fun when students are throwing balls around the room into these different reservoirs and saying the names of these processes as they're doing it. So they're going to use this really cute water cycle diagram to play the game. And it describes all these different reservoirs and all the different processes. So they'll walk away with a good understanding of those and how water is moving, which gives them a good basis for thinking a little bit more deeply about those specific reservoirs and processes and how climate change can affect them. So one of these water cycle processes that's being affected by climate change is evaporation. And after playing the water cycle game, students are going to know that changes in evaporation will also affect other processes like precipitation and transpiration. And it'll have impacts on water in multiple reservoirs. So big overarching impacts on one piece of the water cycle. Evaporation investigation is an experiment where students are going to discover what factors have the greatest effect on evaporation. And there is a video for this lesson as well. So all groups are going to start out by weighing a container of dry soil. They'll sprinkle some water on top, and then they'll take the starting mass with the water. Then each group is going to set up a different treatment. There's 5 different treatments. So we have solar radiation, which is under a heat lamp, infrared ground radiation, which is using a little heating pad, wind that's being modeled by a fan, ground cover that has some fake moss over it, and there's also a control for the experiment. If you watch the video, there is a section of that video that can be shown to students to show them how to set up each one of these different treatments, because there's a couple different rules, like you have to rotate them a certain amount every day and take the mass each day. So you'll have them set up these different experiments, and you'll watch them for 3 days and take the mass each day. And then at the end, they should see some results of which treatments had more evaporation occurring and which ones had less. So they'll see that increasing temperatures, so the solar radiation and the infrared ground radiation, those 2 treatments would have increased evaporation, and also increasing winds would also lead to increased evaporation. So that's a cool, also pretty simple experiment to set up to have them thinking about a specific aspect of the water cycle and how climate change is expected to impact it. And the third one that I'm going to talk about today is Streams and Steam, which is another game that focuses on the impacts of climate change on the water cycle. And it's a Chutes and Ladders style board game. So there's little clouds of steam that are like the ladders you would go up in Chutes and Ladders. And then there's streams that are like the chutes that would carry you back down. And spaces on the board have different causes written on them or changes to water cycle processes due to climate change. And then the effects of that change on the water cycle are on a different space. And so students are going to play the game and they'll land on these different spaces and they're going to keep track of what causes and what effects they land on while they're playing this game. So for example, if somebody landed on this space, number 3, they would land on increased evaporation. And can you guys tell me in the chat, is increased evaporation a cause or an effect? Is increased evaporation a cause or an effect? All right, we hear a lot of effects. Okay, awesome. So this is exactly why I included this, because this is a little bit confusing to me as well. So you'll see that on the bottom spaces, so this is on the bottom of a steam column. So this increased evaporation is actually a cause. So this is something that is happening to one of the water cycle processes. So increased evaporation would be the cause because it's at the bottom of where the students are going to be moving to. And then they would move up the column of steam to space 9 that says more severe drought in some areas. So it kind of helps to give it a little bit of context with the cause and the effect. So the cause is increased evaporation. That's what's happening to the water cycle. And then the effect of increased evaporation is more severe drought in some area. So that's why I wanted to include this example, because I personally think it's a little bit confusing sometimes, but it's really easy to remember if you just remember that the causes are at the bottom of the columns of steam and they're at the top of the streams. So when you're looking at them together, and you're totally right, Stacy. Yeah, it's an effect of climate change and a cause. So it's just the terminology that we use, and when they're paired together, it's a little bit easier to understand which one's a cause and which one's an effect. So we all know how incredibly important water is as a resource, and these changes to the water cycle are impacting everything from super obvious things like fresh water supply, or less obvious things like our food resources or extreme weather impacting human safety. So framing the issue of climate change in terms of something that your students can understand and relate to and learn a lot about in school already, like water, right? It's really important. We all need it. It's a really great way to break down this big issue of climate change into manageable things that students can learn about. And the entire unit of climate change in the water cycle does a really great job of kind of being the whole package, like starting out with some more simple introductory activities like reminders about the water cycle, differences between weather and climate, and then getting into some more complicated activities that look at some of the more specific impacts of climate change on the water cycle. So with that, I'm going to pass it back to Stephanie, who is going to bring us back to the carbon cycle. And if anybody has any lingering questions about that, please feel free to drop them in the chat.
Thanks, Abby. Yes, we're pulling you back from one Earth cycle to another. So here we are back in the carbon cycle. If you attended a workshop earlier, then you may remember this activity, and we had you go to breakout rooms and try part of it. Today, I just wanted to give a quick overview of this because we would be remiss if we didn't mention this one. It's a really, really great illustration of human impacts on the carbon cycle. So the phenomenon we're addressing is how are humans impacting the cycling of carbon on Earth? We're going to go through this really quickly today, but just keep in mind, this one does have an instructional video, which is really great. Actually, you can show the second half. It has 2 instructional videos actually, and you can show the second half of each of those videos to your kids. That way, they can get a really clear picture. They have some illustrations. They can get a really clear picture of how these activities work. So yeah, the links to this activity and the instructional video, of course, will be included in that PDF that we will send out to you by email. All right, so this activity is divided into 2 parts, and they're 45-minute activities. You can do each part on different days if you have 45-minute periods, or if you have a block, you could do it together. Part 1 is a qualitative model. It's a beanbag toss. So students use either a beanbag if you happen to have them. If you don't, you could use some crumpled paper balls or little balls, maybe not bouncy ones, because they will be tossing them and you'll end up with balls tossing or bouncing all over your room. But they toss them to reservoirs, and the reservoirs are all the main reservoirs of carbon on Earth. And they're actually going to scale their reservoirs. They're making them out of yarn, and they'll actually cut them to be scaled to the size of their carbon reservoir, and they're scaling it to petagrams of carbon. Now, you might remember petagrams of carbon as something Dr. Troop talked about, and a petagram of carbon is a ridiculously big number. It's 10 to the 15 grams, or 1 quadrillion grams, which again is impossible to picture. We like to tell the kids it's the approximately equal to the weight of 6 million blue whales. Here in the desert, the kids, of course, haven't seen a blue whale, but most people know that the blue whale is the largest animal on Earth. So again, there's really great instructions for this, but in the instructional video and in the educator guide, if you're more of a person who likes to see instructions in writing, but students will call out the processes that move the carbon from one reservoir to another as they toss the reservoir, as they toss the balls to each reservoir, from one reservoir to the next. The second part of this activity is actually a quantitative model. And the quantitative model is in the form of a board game. So students move fluxing carbon from one reservoir to the next. And what I mean by fluxing carbon, so fluxing is exactly what it sounds like. It's carbon that's actually going to be moving between reservoirs in 1 year of the carbon cycle. In the time period of 1 year, actually most carbon stays put. Most carbon is what we would consider non-fluxing carbon. So non-fluxing carbon, just like it sounds like, it's carbon that does not move in 1 year of the carbon cycle. So to do this modeling, students get a game board, some carbon pieces, some little game cards that actually get cut out, and small clear plastic cups. So again, the materials for this are super simple. Most of them are printables, and then just a couple cheap materials that you can pick up at any store. Let's see, for this activity, students, it usually takes them about 10 minutes to do this part. So what students learn from doing this activity, they are moving carbon from one reservoir to another by drawing these cards, which you can see in the center. The cards have the name of a process, like photosynthesis on the card. And in photosynthesis, carbon is moving from the atmosphere to vegetation as it is absorbed by the plants so that they can do photosynthesis. So they would move 123 petagrams of carbon using the little game pieces that you see on the bottom in that little baggie. So they count out 123 petagrams of carbon and move it from the atmosphere to vegetation. Students do this until they run out of game cards, and the winner of this game is the one who has the least carbon in the atmosphere at the end of the game. So as we know, the goal is to, with climate change, we want to reduce the amount of carbon we're putting in the atmosphere. So the winner of this game is the one that has the least carbon. Students from this activity get a couple main points. They see that the flux from fossil fuel reserves, which is one of the carbon reservoirs that they study during this game, results in an increase in atmospheric carbon dioxide. They take the data that they get from the game pieces that they move on this board, and they actually do some calculations to calculate how much extra carbon ends up in the atmosphere as a result of that that combustion of fossil fuels. And they see that humans are impacting the carbon cycle and affecting the Earth's systems. All right, I will go ahead and stop sharing and pass it back to Kelly.
All right, well, we'll just wrap it up with a little bit of look at what we have coming up, since I know you've seen this slide before, most of you. There's lots to look at online already, and we are really excited about our upcoming units, Climate Change and Wildfire, which is geared more towards high schoolers, and we're looking at the agriculture, food, and natural resource standards there too. So we're hoping that we can get that published. We need to pilot test it in the fall. So if anyone has some high schoolers they'd love to talk about wildfire with, I know for many of us across the West, it is a big deal. It's a big deal every year. But the last few months have been a little rough. Let us know. We'd love to connect with some folks. And the Water Conservation Data Jam. So Data Jam is about creative interpretation and communication of data. And so the Water Conservation Data Jam is looking at water data and how we use water, and how that's connected to climate change as well. So that's a unit that's coming out hopefully in 2022, early 2022 as well. Our newest lesson that we are just getting up online now is called Where's Our Water? It's water conservation here in the Southwest. And in this lesson, students are analyzing data on drought severity, like this picture here. They're analyzing data on population growth and water use across the country to look at, or to make an argument about, will we have water in the future? Will we have enough water in the future here in the Southwest? So it's structured around claim, evidence, reasoning, thinking, which many of our teachers here, I know, really like to practice. I'm sure across the Southwest as well. And this lesson we designed it for remote learning. So it's actually 2 5-minute videos, one where students watch it, analyze the data with the video, we talk through it together, and then they do their claim, evidence, reasoning writing on their worksheet. And then based on their claim of will we have water or not in the future here in the Southwest, will we have enough water, that is, we look at conservation methods that have been used historically here in the Southwest. So that includes our 2 big examples are land contouring and rooftop rainwater harvesting. And there's examples of the native peoples in the Southwest using these for hundreds of years. So these are tried and true methods that are in use today and have been used across the world for centuries. So then we ask students to do a little experiment, kind of building, designing, and testing out their own method, whether that's design a little house with a rainwater harvesting system, or go outside and dig in the dirt and do some land contouring. This is called a waffle garden, which the Zuni people of New Mexico and Arizona use to direct the flow of water and build little berms or big berms, build berms to keep water collected in their gardens. And so have students going outside to dig in the dirt and build this, or doing it inside using recycled materials of boxes and plastic cups and all that stuff. So this lesson can be done really easily in the classroom, but also we designed it for remote learning. So it can be done at home and students can take pictures and share their designs. And they get to do, both the data analysis and thinking, creating arguments, as well as the engineering design work that are both really prevalent in NGSS. And then I just want to give a little plug for our Asombro lessons that we don't have as part of the Climate Hub, but we've published or we've shared online. Stephanie just put the link in the chat, but we have new lessons that can be done anywhere. Before this, most of our work was here in Las Cruces, and that was us going out into classrooms. And with the pandemic year and being unable to do that, we've got stuff we can send to you, whether it's a little individual science kit that can go home with students with all the supplies they need to watch a video and do an experiment in their backyard or their front yard or the sidewalk. Or you can do them together in the classroom, watch a video and do an activity together, or read a book and do an activity together. There's lots of online things where students are looking at data, or students are using computer generated models at the middle school level. And everything's very hands-on, NGSS and Common Core aligned, really easy to use. So there's all sorts of fun things, and it's all very local and desert related. So we've definitely developed things local to the Chihuahuan Desert here in New Mexico, but the Sonoran and Mojave deserts are not that different. There's lessons that apply to everywhere in the desert Southwest. So examples where kids can look at a yucca around town and understand what's going on there, or look at how seeds are moving around in the desert. So that's my plug. The link is in the chat if you want to look at that. You can contact me to get materials. And that is all we are doing today. Thank you for coming, all of you who have been here for our entire 4-part series. We are so grateful, or any piece, any subset of them. Please, please, please fill out an evaluation before you go. It really helps us just to have the feedback to be able to show our funders what you have to say and help us grow, and we take your feedback seriously. Abby, we have kits to give away, and we have the kits are for Insulating You, Insulating Earth, or the ins and outs. It's the experiment with the thermometers and the Mylar blankets. And so we have a class set of thermometers and Mylar blankets that we would love to send some of you. So Abby's gonna share those names right now. As soon as I say, just stay in contact. We're so happy to have made connections with so many new people across the Southwest.
All right, and I sent it out before Stephanie sent out the evaluation link, so I'm going to send it again at the bottom. Thank you, Zoe and Susan and Joe. I have addresses for you already. So I think.
All right, excellent. Well, we will get you those kits in the mail. I will also be sending out a PDF with all the links for everything we've talked about, so you'll get that. As well as we've had several requests for the recording, so I will send those out as well.